Today we're going to be dealing with something called exponents, and this is going to be, um, this is going to be something that we'll see throughout the entire course of the year. Really, I mean, especially with algebra, you're going to see a lot of exponents next year in junior high, and um, even in high school. So, I mean, it's really good that we master this. I mean, we want to master everything, obviously, but um, this is going to be a reoccurring skill that you're going to be needing to use. Um, Exponents, in math, we've got some really large numbers. I mean, some, huge numbers. And so sometimes we can express those huge numbers in ways that are much simpler to look at. And it's just another way of working with numbers. So much of math is learning about different ways of interacting with those numbers, and exponents are one of those. Now, let me ask you, who can tell me, what is an expression? I know that in my class last week, we talked about the difference between an equation and an expression. You know what? I've got all your little names over here. I'm going to see if anybody can answer this. Lupita, can you tell me, what is an expression? Any idea? Well, let's give it a shot. Give me something, because I bet you probably know something about that. You're blank. All right, she's just being honest. I really just don't know. How about Sydney? Do you know? Sydney, you should know this. Okay, give it a shot. Just start anywhere. Writing it not in word form. Okay. Do we? Let's do something here, and we'll do this quite frequently. Do we agree with that? Do we disagree with that, or do we want to add on? Okay, we got a lot of disagreements. Why would you say you disagree, Talis? Well, expressions can be written out in word form. They really can be, just like equations can be written out in word form as well. So, as far as defining expression, whether it's word form or not, or just numerical form, really doesn't matter. What do you think? Yeah. Okay. Okay. So, so you say what about an expression then? Okay, so she says that an expression is exactly like an equation, except it has no answer and it has no equal sign. Do we agree? Do we disagree? Do we want to add on to that? Yeah, I see a lot of thumbs up, so it looks like everybody is unanimous about that. She's correct, and I would say that's a fairly decent evaluation. I mean, like if we had a very simple thing like 5 plus x equals 8, well, it's got an equal sign, it's got an answer, so we would call this an equation. Whereas if we had 5 plus x, that's an example of an expression. Okay? Does that all make sense? Lupita and everybody else? I mean, are we solid now? Okay, so exponents help us write down an expression. There's two parts to an exponent. This is something that you're going to need to become very familiar with the vocabulary. You have a base number. Okay, we call this a base number, and you have the exponent. Okay, the base number and the exponent. Now, some of you, I think, have had some experience with this before, and that's good. We're going to go a little bit beyond that. We're going to stretch you a little bit. But basically, what this is saying is we are going to multiply this base number by itself this many times. Okay? So it should be 4 times 4, which we know is to be what? 16. So 16 can be written out like this, but it can also be expressed like this. It's a different way of doing things. And granted, 16 is not a very large number. Exponents really come in handy for those big, big numbers. But you'll be surprised how fast those big numbers can get here just by changing this up a little bit. Okay? What do you think is the most common mistake that kids make with exponents? What do you think?
They think it's 4 times 2 instead of 4 times
Right. That's very, very true. That a lot of times the biggest mistake, even some of my best math students make this mistake. They understand the concept of exponents, but maybe if because they're rushing or whatever, they'll multiply 4 times 2 and get 8, and not really remember, or just accidentally didn't put down that it should have been 4 times 4 for 16. Okay. All right. Yeah. You mean 2 to the 4th power? Okay, well let's try that out. So she's kind of wanting to explore with us a little bit. If we had, what if we switched these? What if our base number was 2 and our exponent was 4? Would we get the same thing? I don't know. Well, let's play around with that. Okay, we've got 2 times 2 times 2 times 2. Okay. Well, we know that 2 times 2 is what? 4. And 4 times 4 is what? 16. Well, in this case, it works. Now, is that always going to be the case? No. I don't know. I mean, it's worth experimenting, right? Because just because something works once doesn't necessarily mean it's going to work all the time. We learn that in science all the time that, well, yes, this test yielded these results, but will it always yield these results? So let's give another number. Can somebody give me another simple base number and a simple exponent, especially a simple exponent, because I don't want to deal with like humongous numbers right now. What would you say? What? All right, let's try that. 5 to the 2nd power. And that's how we would say that. We would say this not 5 2, but 5 to the 2nd power. And for the 2nd power, we could also say what? Does anybody know? There's another term for 2nd power. That's squared. Okay, I could say 5 squared, which means 5 times 5, which equals 25. Good. Now let's reverse those. Let's take the exponent, make it a base number. Take our base number, make it the exponent. 2 to the 5th power. Okay, so we've got 2 times 2 times 2 times 2 times 2. Now, you know the way I like to look at this is I like to split it up. Now, I already know. Do you already see an issue here? Yeah. Okay. There's no way I can have a base number of 2 and end up with an odd number, of some kind. I can't get a 5, so I couldn't. So, but let's try it anyway. We've got, and I like to put parentheses around this because we don't always have to go, 2 times 2 and then multiply that by 2 and that by 2. Look, I already know that 2 times 2 is 4. And in my mind, mentally, I can already look at this and say, well, boom, this is 16 right here, right? Because isn't 4 times 4 16? Good. Then we want to do those little time saving tips anywhere we can. And now 16 times 2, shoot, we're already up to 32. So no, it doesn't work. And that's one of the other things when testing this stuff out. If it doesn't work once, there's no reason to keep testing it, because if it doesn't work once, then our theory is blown. Okay. All right. Let's try a couple more. How about on your whiteboards? Try this one: 2 to the 6th power. 2 to the 6th power. Let's see what we get with that. All right, so good job on that. Now, there's another type of problem that you're going to see today, and this is where you may have had some experience maybe in 5th grade with exponents before, and that's good. But this time we're going to kind of expand a little bit more. In other words, we're going to give you the answer. Hot diggity! You're already going to be given the answer, 49. And then you'll see maybe like a comma, and then it will say base 7. So what does that mean? It means this. It means the answer is 49. Woohoo! You guys like mysteries? Yeah. I love mysteries. You got to figure something out, right? And this is sort of a mystery, but as a number mystery. Very good. The base is what? 7. So what you have to figure out is, what is the exponent? We have to figure out what the exponent is going to be. We know that we get 49, and we are obviously multiplying 7 by itself some amount of times until we get 49. This is where having a good, remember, I told my class last week that, of all of the math facts that you could really study, and those that are probably the most useful, multiplication would definitely be it. And for those of you that have really good multiplication facts, they're going to help you when it comes down to exponents. So if we had 7, and I'm thinking about 7 times, you guys, a lot of you already have your answer up. 7 times 7 is 49, right? Agreed? So what would our exponent be? 2. To 7 to the what? To the second power. Good. Or 7 squared. Yeah. Very good, guys. Very good. What if I had this? What if I had 27 and a base of 3? You can figure that out. Just on your whiteboards. 27, base 3. We want to know what is the exponent actually going to be. Okay? So we know that the answer is 27. We know that the base is 3. We just got to figure out what is that missing number? What is that exponent that we're looking for? Catherine, where are you? Catherine. Oh, she's so wounded. Catherine, can you tell us what's going on? Can you tell us how you did? Because let me see your board real fast. Okay. Can you explain what you got? Show everybody what you've got so that we know what you're talking about. Okay. Explain. Right. Okay. Do we agree with Catherine? Do we disagree with her, or do we agree with some of it, or we want to add on? Because I don't. A lot of you are saying disagree. I don't completely disagree with her. What does she have? What does she maybe need to fix? Who could give her maybe a little bit? You can sit down, Catherine. What does she need to fix, perhaps? Yeah. Instead of 9 times 3, we want to make this 3 to the third power. Now, I know what you're thinking, Catherine. You were kind of working this out. She said, okay, well, it's 3 times 3 times 3. And this is why I didn't disagree with you entirely, because I kind of knew where you were coming from. You just got confused in showing it. You're saying, well, this is 3 right here. I mean, this is 9 right here. And 9 times 3 gets me 27. Yeah, you're absolutely right. But you wouldn't want to represent that as 9 to the third power, because that's going to be something a lot greater than 27. A lot greater than 27. Okay, so good work. How about another example here? 32 and a base of 2. Okay, yeah. 32 and a base of 2. You know my answer is 32. I know my base is 2, so that means I'm going to multiply 2 by itself some amount of times. Okay? Start working that out, man. Start working it out. Well, no, not in your head. Just start writing stuff down. I mean, I would go like this. I go, no, 2 times 2, I know that's 4. That's really far away from 32. So 4 times 2 is going to give me 8. Okay, so I know that's 8. I'm still far away from 32, but getting there. 8 times 2 is going to give me 16, right? And 16 times 2 is what? 32. Ding, 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 ding. We're there. We don't need to go any further. So, therefore, what's my exponent going to be? A 5. I need a 5 up here. Okay? 1, 2, 3, 4, 5 twos. So 32 equals 2 to the fifth power. Got it? Okay. Practice some more of those. All right. The last, I guess, application that I want to show you when it comes to exponents is that first of all, math exists in in all fronts. Don't think that if you're really good at math that you're only career choice is to be a mathematician or a math teacher or something like that, because math exists everywhere. I mean, it exists in the kitchen. You know, if you're a chef, it exists on the work site if you're a construction worker, um, and it definitely exists in science. Science and math go very much hand in hand. Um, you know, in California we have earthquakes, right? I mean, I don't know. We haven't had one, at least a serious one, in a very, very long time. In fact, I don't know if you guys have ever felt a serious earthquake. Um, they do happen from time to time. Where we're at, we don't feel the full force of earthquakes like some people, maybe like Bay Area or Southern California, sometimes get some pretty big shakes. But earthquakes, if you've ever lived through even just a little one, like a moderate one, they can be very scary. I mean, you know, they can be very scary. I have never lived through a major one, and most people, I would imagine, can't say that. You know, something like what happened in Haiti, you know, a few years ago, where it was just this devastating earthquake. But, you know, earthquakes are measured. There's a type of measurement. There's a type of measurement that we use with earthquakes. Do you know what they're called? No. Well, a seismometer is the machine that measures it, but then it takes that information and there's a scale that we use called the Richter scale. A Richter scale. And we hear this all the time on the news. Whenever there's an earthquake, they said, "Oh, there's been a 6.0 earthquake, magnitude earthquake. 6.0 is 6.0 on the Richter scale." But that might not mean anything to you. Okay? It didn't mean much to me either until I looked at this. Take a look. Earthquake strength. All right. A moderate earthquake is nothing to sneeze at, so to speak. A moderate earthquake is, you feel a moderate earthquake. This would scare you. It's enough to scare you. It's enough to maybe knock some things off of shelves. You would definitely feel the rumble underneath your feet. It's a far cry from the earth opening up and swallowing vehicles and things like that. But yet, at the same time, you know that, you know what, I need to get to a safe spot. Okay? Moderate earthquakes happen frequently. I've felt moderate earthquakes before, and I don't like them. I don't like any of these earthquakes. But you know, when we see, like, you know, we hear about, okay, in one part of the world maybe there was an earthquake that was a 5, and then another part of the world it was an earthquake of a 6, and then there's a 7, and there's 8, and you think, well, 5, 6, 7, 8, they're right next to each other in a number line. That there's not that big of a degree of difference, but there really is. I didn't really understand this until you really look at it. There is a large earthquake, what we would call a large earthquake, is actually 10 times greater than a moderate earthquake. 10 times greater. Sean, I need you moved up here. I just don't like what I'm seeing, so just move yourself. Yes. It works its way up. You know, a 5.1 is a little bit stronger than just a moderate earthquake. Still in that moderate range, but it, you know, as it gets up higher, once it gets to 6, like 5.9 is almost a 6. That's pretty, you know, we're pretty much 10 times that of what would be a moderate earthquake. That, so imagine that shaking 10 times stronger. That's a lot. But then check this out. A a major earthquake is considered a 7. Well, what's 10 times 10? 100. So a major earthquake, even though it's like, okay, you know, maybe you had an earthquake that was a 5, and then there was an earthquake of a 7. You think, oh, 5 and 7, no big deal. Are you kidding me? This earthquake is 100 times greater. 100 times greater. So picture in your imagination that the effects of a moderate one, where you know things are falling off of shelves, and now picture like that of a major, where it's not things falling off of shelves, it's the shelves falling off of the wall. You know what I mean? I mean, this is now getting to be very serious, very serious. This is when cracks start developing in roads and you know stuff like that. And then of course, you know, worst case scenario here is what you call a great earthquake. We haven't had a lot of these, but boy, when they happen, they cause major devastation. Major devastation. Because if you think about it, again, moderate, you feel it. They make you kind of nervous, make you kind of scary, but you're probably going to be okay. But how much greater is a great earthquake than a moderate?
1,000 times.
Yeah, we've got 10 times 10 times 10. That's 10 to the what?
Third power.
Third power, which equals 1,000 times greater. 1,000 times greater than that of a moderate. And to me, I can't even imagine that. That's when you do see like giant cracks all of a sudden opening up on the earth, and you see buildings collapsing, and stuff like that. I would no, it's not pretty at all. And I mean, I would love it if none of us ever lived to see a great earthquake. That's just kind of spooky. But anyway, um, this is an example of how we use exponents to, in maybe like in the field of science. In biology, you can take like a bacteria that divides itself and then divides itself and then divides itself and then divides itself. Again, we're going to be using exponents, to see like how much bacteria will there be in 5 minutes if it divides itself every minute, whatever. There's lots of different applications for exponents in science.